how do we um, how do we evaluate an arithmetic expressions in Java? So when we in real life we write an expression, a mathematical expression like this, but you have seen in C that this is not how we program it. So this is translated to this. So the important thing is 4x, it actually means 4 times x. So you have to mention this explicitly to be 4 times x. And also here it's 10 times y minus 5. So you have to write this 10 times y minus 5. So this is the exactly same way you have done in C. Okay. So again, in order to evaluate an expression, we use the rule of preference. So the first preference is for the parenthesis. So whenever you have a parenthesis, you evaluate it first. So after the parenthesis, if you have multiple addition, subtraction, and multiplication, remember that the multiplication, division, these have higher precedence, so they will be executed first. And if you have now multiple multiplication or multiple operation of the same level, which one should you perform first? As a human, we know whichever we do, 4 times 4 or 5 times 7, whichever we do first, it will not change the result. But we need to give specific instructions to the computer, and that particular instruction is, if you have multiple same level operations, do it from the left side. So if we have two multiplication, we need to calculate the left one first and then the right one. Then we are left with two pluses and minus, one minus, again same level of operation. So we need to perform the leftmost part, then the next one, and then the last one. This is how we evaluate an expression in Java or in C. So let's look at the next slide sometimes. Okay, so next the shortcut assignment operators. So we have used the same things in C. So if you write like this, plus equal, like this, I plus equal 8, it actually means I equal I plus 8, or minus equal means f equal f minus 8.0. Next we have increment and decrement operators, that is plus plus and minus minus, and they actually increment by 1 or decrement by 1. So we have two types of these operators. One is called pre-operators, that means pre-increment, and the other one is called post-increment. Okay, so one is pre-increment and post-increment. So what's the difference between this pre-increment and post-increment? Because increment means increment by 1. So what does this pre and post means? Let's look at an example. So let's declare a variable I and have the value 10. Okay. So 10. Now if we simply write like this, I plus plus, and just let's see what the value of this variable is. It's a print ln, okay, and I, okay. So let's restart it for now. Save. Okay, so while it's restarting, let's see, this plus plus var means it actually first increments the value of the variable by 1 and then use the changed value to wherever you are using it. And when you have post increment, it means you first use the current value of the variable to wherever you are using, then you increment that particular value. So either way, at the end you will have that particular value incremented by 1. The difference is basically into how you are using that variable with something else or in another expression. So let's look at next example with this. Okay. So here I have this example. So int I equal 10, and when you have this int new num equal 10 times I plus plus, this is the same as, that means look at this, I first then plus plus, meaning you have to use the current value of I here in this expression, and then afterwards you plus plus the value of I. So this is same as this int new num equal 10 times I, then I equal I plus 1. If you have this as pre-increment, that means like this 10 times plus plus I, meaning you first change the value of I by incrementing 1, then you use the changed value by multiplying with 10 and storing it here. So you first increment the value of I, then you use the value of I. So this is the main difference between the post and pre operators. So next we look at some basic rules. It's taking some time, I don't know why. So okay, so using this increment and decrement operators makes expressions short, but overusing it may make your expressions very complex and difficult to read. So now let's look at type conversion. That means when you change one type to another. So let's say we have this expression byte I equal 100, and then long k equal I times 3 plus 4. So I, the type is byte, and we have 3 and 4, and by default any whole number is treated as integers, that means 32-bit. So 3 will be converted to 32-bit, 4 will be expressed with 32-bit, but I will be expressed as 8-bit. And the result of this expression will be kept into long type, that means in 64-bit. So and then here double D, that means 64-bit fractional number. Here I is byte type, so 8-bit. Then we have a fraction 3.1, so we have seen this is by default 64-bit double. Then K is long, so 64-bit, and 2 is integer 32-bit. So we see that in these expressions there are a mixture of type, and ultimately we are keeping it some other type maybe. Okay, so what's the rule in which type they will ultimately be converted into? So let's look at the rule now. Okay, so when performing a binary operation, the rules are if one of the operands is double, the other is converted into double. Otherwise, if one of the operands is float, the other is converted into float. Otherwise, if one of the operands is long, the other is converted into long. Otherwise, both operands are converted into int. So in general, it means you should convert to the higher size. That means here I is 8-bit and 3 and 4 they are 32-bit. So when calculating the size of the actual result, you should convert I, the 8-bit, into 32-bit and then perform the operation. Okay. So now type casting, that means again you want to change the type of one variable into another, and there are two types of casting, implicit and explicit. So implicit casting means when we have something like this, double D equal 3. So you see 3 is a whole number, so by default it will be considered as an integer, but you are storing it into a double value. So integer is 32-bit and you are storing it into a 64-bit place. That should not be a problem. You can actually place any smaller object into a bigger place. This is known as type widening, and this type of conversion or casting does not require anything explicit from the programmer. That's why it's called implicit casting. That means this casting is done automatically. So when you again want to display D, it will show you automatically 3.0. Next, explicit casting. That means this casting is not done or cannot be done automatically. The programmer needs to do it explicitly. So if you write like this, int I equal just 3.0, so 3.0 being a fraction will be considered as double. So double is 64-bit, and when you want to store a 64-bit object into an integer which is 32-bit, it cannot fit. It's because 64-bit is definitely bigger than 32-bit. So it will give you an error. What we want to do now is we want to have this written explicitly. So before this 3.0, we will write in parentheses int, meaning change this value into integer. What will it do? It will just discard whatever is in the fraction and then just give you the integer part. So when you want to cast between character and numeric type, it can be done implicitly, because you know a character is basically an ASCII code, and ASCII code is integer values. Okay, so if you write like this, int I equal this character A, so in that I, it will actually store the ASCII value of A, which is 97. Similarly, if you write character C equal 97, so when you want to reuse that C again, it will give you A directly, because 97 is the ASCII code for small a.